I will go on with automatic lidars and ceilometers. That are the next system we want to introduce. These are optical instruments that we use for aerosol and cloud profiling. We can think of them as simple aerosol lidars, usually working on one single wavelength. As for some of the other measurements that we have heard before, they are very low maintenance and operate in basically all weather conditions. The main products that we directly get from the sensors are cloud-based height and attenuated backscatter profiles. The measurement principle is a bit similar to the lidar, Doppler lidar that Ewan mentioned before, only that we have one beam that is continuously shooting in one direction into the atmosphere, where it is partly absorbed and partly backscattered into different directions. And some of this light that is scattered back into the direction of the sensor is then received or collected by a receiver. And depending on the round trip time that it takes for the light to travel up and down the atmosphere, we can construct this profile of attenuated backscatter, which also, of course, depends a bit on the characteristics of the lidar itself. As we have quite a lot of different systems out there, so we have ALC from a range of manufacturers that are working on different wavelengths. We see that we have quite a diverse operation going on. Some of these measurements also have depolarization capabilities. This is a technology that has just recently come up in the ALC technology, and it helps to distinguish different aerosol particles. In general, we see very fast moving advances in the ALC technology, both in terms of hardware and the instrument internal software. And this leads us to the situation that we need to keep in mind that the capabilities between the systems can differ, and we therefore have also a different type of data quality. And this is not only between instruments from different manufacturers, but also because we have different generations and advancing products from one manufacturer themselves. So it is part of the probe initiative that we understand how these systems can work together and how they compare. And due to these advances in technology, we can now record attenuated backscatter profiles at very high resolution, lower than 30 meters in the vertical, and very high temporal resolution. There are two very important instrument characteristics that affect the attenuated backscatter, which is the optical overlap between the receiver and the transmitter beam. So close to the sensor, the receiver telescope may not see the whole beam that is transmitted out to the atmosphere. So we have to correct for the incomplete optical overlap, and maybe also account for the fact that data may not be usable very close to the sensor itself. In terms of data quality in the higher ranges, the signal to noise ratio is an important aspect, because the further we get from the sensor, the higher the noise that contributes to the signal. Usually we have rather high aerosol content in the atmospheric boundary layer, so the signal to noise ratio is really good. And some of the advanced ALC are also able to measure molecular scattering in the free troposphere. Here, for example, we see a comparison to an aerosol lidar. Of course, we have more noise from in the ALC, but on average, there is some good agreement. The other product that we get from the ALC is the cloud-based height. So some of the ALC that are measuring are only recording the cloud-based height, but more and more instruments give also the attenuated backscatter profile. We have a very strong signal from the clouds, because they give a very strong attenuation of the laser beam. If we have a very strong, thick water cloud, the beam is fully attenuated and we cannot see what is happening above the cloud, which is, for example, the case here above this cloud. But if we have broken clouds or thin clouds, we can actually detect several cloud layers at the same time. And these products are provided by the instrument internal software. Not only the cloud-based height, but also cloud cover products can be obtained. For example, here we see a map of cloud cover across Europe, across the eProfile network, which shows very nicely the ALC networking capabilities. And these products are widely established and already used in NWP data simulation. In probe and previous cost actions, we have worked very hard on correction procedures that are necessary to improve these products from the ALC, and also to see how what needs to be done to actually get real quantities of attenuated backscatter in absolute calibration. So we continue working on these aspects to get very high or quality products from these rather simple sensors. As mentioned before, the strength of the ALC is that we have very many in operation. Across Europe, we have hundreds of ALC operated by national weather services, but also academic sites and at airports and so on. And it's part of the probe initiative to work towards harmonization of these networks. In terms of advanced products, we can use ALC for a lot of different things. One very popular aspect is the tracking of elevated layers that may be moving above the ABL, but then also may entrain into the atmospheric boundary layer at some time. For example, here, if you go to this, to the eProfile example here, where they tracked Saharan dust moving across the continent using the ALC network. And also, we need to mention that the new depolarization capabilities of some of the ALC can be used to better characterize the different aerosol types. Another application of ALC is near real-time fog alerts. We can use the fact that the attenuated backscatter of the ALC captures the hygroscopic growth of the particles, and we can use this to get information on fog formation. And there are within probe some algorithms being developed to get early warning of fog situations at different European airports. And finally, there's a lot of work happening for the automatic detection of the boundary layer height, which includes the mixed layer height and also the residual layer heights. We have several different automatic algorithms that are being compared and evaluated with very improving performance across the board. And also there's work done to characterize the ABL both in terms of cloud type and aerosol signature.